Okay, so we've been doing pictures of the data. So we made a lot of different graphs last week, and now we're going to do descriptors of the data in number form. So this whole section is descriptive stats. We started with there's descriptives and there's inferentials. Inferential starts next test. So this is still descriptive stats. So we're going to do a group of stats called central tendency. That's your mean, median, mode. Have variability, that's standard deviation, and variance. So all of statistics, this is a gross oversimplification, but it's this idea that variability does matter. So everyone's not the same. Numbers are not all the same. And so how do we summarize variability? So how do we create a picture of the data in a simple way without telling each person every single data point, because that wouldn't work. So variability matters is sort of the way I think about stats. Like, how do I describe the variability? Less is more, depending. So generally you want statistics to have less variability, because when we get to talking about hypothesis testing, like actually running the inferential stats, a lot of variability means that you don't really know what happens. So we tend to want really small standard deviations. But the depending part, you don't want no variance. So some variability is good, no variability is usually bad for you, and a lot of variability is bad. So we got to find like sweet spot of enough variance for this to mathematically run, but not so much that we don't know what's happening in our study. And error happens. So it'll be pretty rare that you get no variability, because people are weird, and you don't know why they're weird, they just are. So you'll get some variance. It does happen because I know when I'm helping people with their statistics, especially like structural equation modeling, the really like fancy cake stuff, one of the most common errors is that there is no variance. And people don't think about that because generally, like the problem is you got too much variance. Okay, so to have no variance is a little weird, but it happens. All right. So starting with central tendency, okay, which is the like umbrella term for all three of these. So mean, median, mode are all types of central tendency. So central tendency is a descriptive statistic that represents the center of distribution, but we have different types of centers, so we're going to use different ones. So we have a nice normal distribution. Remember, normal is unimodal, hot dog folds, symmetric. We might go with the mean. If we have a skewed distribution, I don't know so much about the mean. So the mean, y'all know what the mean is. It's the average, right? The problem with the mean, and I have a slide for this a little bit later, but I was going to try to draw some pictures for you, is that in a skewed distribution, it's pulled more towards the tail, because means have to weigh the score, and so it's moved more towards the outlier score, or the tail of distribution. Okay, so they are skewed in the direction of the skew. So if the skew is positive, the mean is higher than normal. So they call the mean the typical score. I don't know that I would describe it as the typical score. And then sometimes it's described as the middle of the scores. But I wish the book wouldn't do that, because that's confusing, because the median is literally the middle. The mean is the middle of the total of scores, not the middle of the people. Right? So you can think of the mean the way you always think about the mean. It's the average of the scores. But 50% of the total of the scores will be on each side. So if I have 100 points over here, I have to balance it out. So if you were to do one of these by hand, okay, the only reason I want to show you this sort of thing is because of the symbols, and the symbols do come up on the questions. So you would add them all up and divide. We're not really going to do that by hand. But the symbols, if you haven't seen these in a while or never seen them, this sigma here, the little e, is add everything up. So each person, so we got sigma. person is represented by an X, or each score. You don't have people. And then N is the total number of scores, or people. Instead of using X bar, because that's more traditional, like the hard sciences, we tend to use M for the mean. The book does X bar, but M is the same thing. So this is what I want to show you about, like, it's the middle. So the median is like the middle of the squares. So the mean weighs how much each square counts for. Right? So I've got a skewed distribution, so positively skewed distribution. So instead of being closer to 2, which would be the most scores, it's pulled towards those 10s. So it has to balance out the fact that 10 is more points than all those 2s. You probably never thought about the mean that hard, really. Or like, I just add them all up and average. Right? But most parametric statistics, so the stuff we're going to do in this class, report the mean. It's a good representation of ratio data. So we're really going to use the mean for scale data. So that continuous stuff. So it's a way to take one score, or one distribution of scores, and sum it up with one number. So quick note on the symbols. Usually we're using Latin letters, that's your alphabet we write with, for samples. So you'll see sample statistics. It's very mnemonic, it's kind of cute. So MSD for standard deviation. If you're seeing Greek letters, it's populations, population parameters. The way I keep that straight is it's like, I always think of it's Greek to me where these numbers came from. Feels like you pulled them out of thin air. Because population numbers you just have to have. So they have to give you the number. And then all the letters are going to be italicized. And that's APA style. Most of the stuff we're going to work with in this section is going to be all sample stuff. So we're going to have Latin letters. Yes. Okay. So, for fun, I feel like we've been like, work. We're going to take a quiz. It's fun. And use it as data. So we're going to cover a little bit today. How do I get data into R where I don't have to use Excel? And also, how do I calculate this stuff? So here, I click on the link. It's going to take you to Sporkle. It's going to give you logos for companies. You just click play and you start typing. You do have to spell it mostly correctly. Okay. So a lot of the questions that are coming up on homework and Launchpad, sorry, brain fart, is dealing with entering raw data, especially when we get into some of the next sections. So instead of importing it through Excel, I thought we talked today about like how you can just like actually type it in. If you have a lot of data, this isn't very good. But if you have a small amount of data, this works pretty well. So we're going to use the C function. It stands for concatenate or combine or caret, however you want to think about it, right? So combine everything together. Okay. Because this will be one column of data and it's not in a data set, you're not going to have the $sign operator. Okay. So you would just call it my column. And so it'll appear in a different place on Studio, and I'll show you how that looks in a second. Okay. So if it's one column of data, there's no data set that it's in, so there's no $sign thing. If it's lots of columns of data, you have to tell it first where it's at and then use the column name.
Are we going to need to open ggplot?
No. No. All right. So we're going to start by my column, right? Or whatever you want to call it. You can call it cheese. Okay. That's C, open and close parentheses. And then we're going to type these numbers in. Okay. So they got to have a comma between each one. I just did mine. I hit enter in the middle so I could see it the whole time. You don't have to though.
Will spaces affect this?
Nope. Spacing sometimes matters, and unfortunately it's difficult to explain when it doesn't. Alright, so I'm going to run both of those once you get it typed in. You'll see it's over here under values. Trying to show you the difference here. There you go. Okay. So when you have a full data set with columns, it appears over here under data. Right? And it gives you the little drop down option to look at what the columns are. But when you have one column of data, it appears under values. Okay. So it tells me that that's a number. There, it's numeric. And there are 18 values, so there's 1 to 18. So the ones with the columns that you can like click on and look at are data frames. And so that's when I have to use the $ thing because otherwise it doesn't know what the column is. Because first it's in there equality. Okay, now here's the column name. But it's down here under values. It's just one column of data, and I can just call it my column. And so if you're trying to figure out, you're looking at one of the questions is asking about skew, and you want to make the histogram, you could type in the numbers that they gave you, and then use ggplot and do the histogram thing. All right. So how do I calculate the mean? There's 2 ways. The first way is probably my favorite. It's the summary function. The summary function is this really versatile thing that will summarize whatever you give it. So if you give it a column of data, it summarizes the column. If you give it a data frame, it summarizes all the columns. If you're running an analysis like an ANOVA, it gives you the output for the ANOVA. So it's really, I can't really describe what it does because it's like the jack of all trades. Or the other function is mean. Okay, fill in your column name. And this thing I think is new. We haven't covered this thing. Okay. So NA.RM stands for what do I do with NAs? Okay, so NAs, remember, I'm missing data. Maybe not remember, but new thing. It's missing data. .rm for remove equals true. So this will remove missing data. Right now we don't have any missing data, so it's not a big deal. But later, if you did, for whatever reason, and you don't include that, it'll just give you an NA back. If you never have been told, like, oh yeah, by the way, if you have missing data, it won't give you an average, you're not really ever sure what to do. Okay. So I always type it even if I know it has it doesn't have any missing data, because then I can't forget. Right? So a lot of the things I'm going to give you are things that you don't necessarily have to do, but when that time comes and you need it, you won't have forgotten it. All right. So let's try the summary function. Okay. And I'm just going to type my column. There it goes. So we should get this stuff down here. Drop this into Word real quick, make it a little bigger. So what does it give me? Well, it gives me my min and a max. Okay, so 10 to 24 is the range of the data. First quartile, third quartile, we're going to talk about that later. It actually gives me the median, which we're going to talk about next. And then here's the mean. So what it does, kind of a nice pretty way, is it gives me the top, the bottom, it breaks it into 4s, and then it gives me the mean. The mean is the 50th quartile, right in the middle. Yeah?
I don't have the same numbers.
Yeah,
I don't either.
Then we typed something slightly like how different.
Like, mine goes 10, 15, 16 and a half, 16, 18, 20.
Yeah, so mine goes.
That's
Mhm.
not
10, 10, 16, 15, 15, 24, 10, 19, 18, 16, 18, 12, 17. Oh, I left out a 17. Or maybe I made it a 12.
Yeah, you made it a 12.
Ah! This one should be, oops, don't do that. 17. At least it ran. I was about to be like, okay, why didn't it run? There we go. Sorry. Can't read my own handwriting. Okay. But if you're looking for the mean, it's the one under the mean. Okay. But in this format, it's giving you the ends the quartile, so where 25% of the data is, and the 50th as well. One way to tell, and we are about to go here, one way to tell if a distribution is fairly normal is if the mean and the median are roughly the same. Okay. And they're pretty close. If the mean and the median are very different, it's a skewed distribution. The other way you can do it, if you don't want to get all the numbers, is just the mean function. It is not average. I've typed that so many times I can't even tell you, but it still isn't average, so it's mean. So my column, and then just keep in the na.rm, and you can do t for true. And then that'll give me just the mean. So it gives you more decimals. So I like to use the summary function because it gives me a lot of information, but if I'm trying to write something up and put it in a table, I might just use the mean function so I don't see all the rest of that stuff. So it kind of just depends. Which one you like better? All right. So then we're going to talk about the median. So the median is the score that's directly in the middle when you order them from lowest to highest. So if you put every single person's score in a row and found the middlest one, that would be the median. In a normal distribution, it's fairly close to the mean, because the mean is the middle, and the median's the middle. In a skewed distribution, it's not going to be the same. It'll be more towards the peak of the distribution. So the median is actually a great representation of still scale data, but skewed scale data. Okay. This is better if it's normal. So if you've ever wondered why they always talk about median income levels, it's because income is very skewed. You have lots of people on the bottom, and then a couple scores on the top. Especially if I like to pick on Dallas, because I love Dallas. But there are, what, 3? But Kansas City would be a good example, too. Maybe Dallas, yeah, like 3 major athletic teams. Mm-hmm. Yeah, so distribution of income is very skewed for Dallas. So they always talk about median level incomes, or even if you look at housing prices, they give you like a median house price. Because if they gave you the mean, you would run away screaming, because it's going to be pushed towards the higher numbers. And there's no real symbol for median, but MDN, you can type out the word median too, it's fine. So the mean is going to be pulled towards the tail. So if I have the skewed distributions, the other skew, it's going to be towards the tail. The median's towards the peak. And then, if I wanted to calculate the median by hand, good gracious, this is like, if you have those like little letter blocks as a kid, right? So you'd line them all up in a row, count, figure out which one's the middle. If you have an even number of scores, it will divide by 2. So sometimes the median is not a score that's actually in the data set, but it's still between the 2. That's way too much trouble. So we can just look at the median with the summary function, or you can use median, column name, and that same na.rm.
Would there ever be a situation in which the median or the mean function would be better than the summary function?
Mainly if you just didn't want to see all of it. Like, I'm trying to write a report and I don't want to have to think about what all these numbers are. So I tell it to go through all the columns and just give me the mean of each column without having to see all of it. Does that make sense? But generally, no, I use the summary function. Yeah. Yeah.
I see out here that the mean is giving me 5 decimal places.
The function, yes, it'll give you more. Yeah. That too, I guess, if you wanted more than 2 decimals. Summary just gives you 2. R will calculate, I think, 18 significant digits. but then it just kind of gives up. All right, where was that? Oh, median. So we've already seen the median, 16.5. Right, so we don't have a 16.5. So we clearly have an even number of scores, so it took the average of 16 and 17. But I can also do median. Okay. And that'll show me it's still 16.5. Yeah. I do love the summary function. It's fantastic. Okay. And the last of the central tendencies is mode. Unfortunately, there's no cute mode function. It's really dumb. But I found a cheat last night on the internet. So your mode is your most common score. So we're really going to use modes for discrete data. So, one problem that we have with the intro to psych pool when we're asking people to take our studies is it's 60% women. So women are the mode. So it's always the largest frequency, or the largest percent if you're looking at a table. So it could be the highest bar on a histogram. That depends on your bandwidth, though, because that might be several scores in that one bar. Or the highest point on a frequency polygon. Sometimes you get multiple modes. And that's a be careful on your homework thing. The cool thing about R is that it will show you both of them. So it's the most common score. You would find the most common one. So I got these from the book, and I just was like, I'll leave this in because it's funny. Like, really, this isn't that hard. But the book, that's the slide from the book. That's the mode. Anyway. But let me talk about distributions real quick. So we talked about last week pictures of the data, or a couple weeks ago. Unimodal are distributions with one hump. Bimodal have two modes. Multimodal has three. But if you are manipulating bin width, which we did, and there are 10 5s and there's 10 6s, technically that's two modes, 5 and 6. But because of the way that we graph these pictures, it looks unimodal. Right? So 5 and 6 are both modes, but I wouldn't call that bimodal because it's 5 and 6. It's still unimodal. And so when you're looking at these pictures that they give you online, they try to not do that to you. But technically a distribution with 10 5s and 10 6s and everything else is smaller is bimodal. Although when you look at it in a graph, you're like, that's unimodal. So I'm going to try to leave these terms to the way they look, just visually. Like unimodal's got one hump, bimodal's got two humps with something, a dip in the middle. And then then the other questions will just be, what are the modes? Because this is a very technical definition that nobody really uses that way. Does that make sense to people? Yeah, a little. Yeah.
How would you are there terms for ranking the modes? Because even in multimodal curve or bimodal curve, one of the modes will be more significant than the other will. So
Taller? Well, they're exactly the same. They're both modes. If you have a distribution like that,
yeah.
I would call that multimodal.
Mm-hmm.
But technically only the one in the middle is the mode.
Okay.
Like, for the definition of mode being the most often score.
Okay, so you would make the middle one, you would say that's the mode.
Mode. But this distribution is multimodal.
Okay, is there a way to describe the two? Is there a term to describe?
I would say the second highest scores.
Okay.
Yeah. And that's why I have this slide. Because visually that's clearly got multiple humps. But when we're talking about mode, it's literally the one with the highest frequency. And so we're going to kind of separate those two things. All right, calculating mode, not as much fun. If you see this symbol, I forgot to fix this. That's equals. You can also type equals. This is the snobby programming version of R. I'm like, that's like 3 extra key presses, and it's not as nearly as efficient. But we're going to copy this, and the only thing that you're going to change is where it says column in italics here. So remember, I tried to make italics where italics is what you have to change. Now, if you're going to cut and paste, oh, it worked. Sometimes, like if I'm on my Mac, it'll copy the little bullets. Be sure you delete those. So what this first thing does is it creates a sort of temporary data set that's set up in a slightly different way in R as a table. So if I look at what is in temp, it's a frequency table. So the first thing that happens is it sets up a frequency table for you. So be sure if you're running this, you change this to my column because that's what we called it. The next line down gives you the one that has the largest frequency. The names function says, tell me which label here has the highest frequency. So we're going to have two of them, right? 15 and 18, because they're both 3. So it gave me 15 and 18. So the only thing you have to change on that is where it says the column name. You could just create yourself a table and look at it, but if you have thousands of data points, that's a lot of work. So this little function will do it for you kind of quickly. All right, so let me do a couple more slides. Oh, I was writing. Okay, so mode is really good for discrete data, but on a distribution that's not discrete, it's going to be the tallest point. So in a perfectly normal distribution, like this perfect distribution that never happens, right? The mean, median, and the mode are all exactly the same. And so the closer they are together, the more normal the distribution is. The further apart they are, the more skewed it is. On a skewed distribution, remember the mean's always going to go towards the outlier, bless you, or towards the data.
Whoa, sorry.
So while it seems like our numbers have some outliers, it kind of looks like it's fairly normalish because we've got a lot of people in the middle and then people on each side. We've already touched on this a little bit, but why all 3 numbers? And then why is that not the end of the story? Why we have class on Wednesday, basically. So central tendency is not always the best answer because of distributions like this. And that is a pretty rare thing to happen, especially that pretty. But that would have one mode, and the mean and the median would all be the same number. So you would think it would be a normal distribution until you looked at a picture. So that's why we spent last week talking about pictures. They're also still really important. Because then you're going to see that and you go, oh, well. Because even though it has the mean, median, and the mode are all the same, that is not normal at all. And so we would have to find some way to deal with the fact that this has multiple mini distributions. And one other problem we're going to have is outliers. So one thing to solve this issue, right, is to talk about variance, and that's what we'll do on Wednesday. Talk about the spread around the middle. So is it a skinny distribution or not skinny distribution? So we're going to talk about kurtosis again. But then also another issue is outliers. So I've kind of actually already written the answer to this question on the board, but which one is the best? If you ask people, most of them say the mean, because that's what you see all the time. Like it's just the thing that people present. But it's really not. If you have a skewed distribution, the median is actually much better. Because otherwise the mean is pulled way towards the tail. So in this example, right, the mean on whatever scale this is 991, but there's only one person whose score is higher than that. And so if you tell people the average is 991, everybody else's scores are below that, so it's not a very good representation. Whereas the median, right, would be here where most of the data is. Okay, so the median is much better for skewed data. The mode is better for discrete data. And the mean is good for scale data that's normal-ish. Okay. So if I take the mean without the outlier, I do much better. So we're going to add an outlier and run those lines again. So what do we want our outlier to be? 200. Okay, sure. It's not a real score, but... So we can use that C function again to add a score. So I'm going to call it outlier. So outlier equals C. So my column. I'm just going to add one more score to my column, so this will combine my column and this score. Smush. 200. So you'll see the outlier column over here in my window is 1 to 19. Okay, so it just stuck 200 on the end. Since I've called it the exact, I haven't called it the same thing. Sorry, different lecture. I can copy all of this. So we can just run the summary function, but instead of calling it my column, it's now called outlier. So our mean before was what, 16 something? The correct mean, and not the typo mean. There we go. 16.22. It's now 25. So that's a pretty big outlier. So the mean moved towards the outlier, towards the tail, but the median didn't really change. So the median is really good for skewed distribution. And then if I do the mode thing again, I still have to change this here. Change it in the right place. Oh, I got excited and deleted the wrong thing. There we go. Outlier here. And the mode is still 15 and 18. So there are a lot of questions in the homework about what do outliers do. They're going to affect the mean the most. Okay, so they move the mean towards the tail. So if we added a negative outlier, like negative 200, it would have moved down. Okay, it's going to move towards the outlier. And if you aren't sure, make a picture of it. So use ggplot, make a histogram. Okay. All right. So last slide, because it's a good place to stop. If we delete outliers, the mean will move back towards the middle. So the mean is the most affected by outliers. And the mean is the best for a symmetric distribution. So this is a summary of everything on the board. With outliers, the median is going to move just a little bit. So the median is best for skewed distributions or things with outliers. And generally, the mode isn't going to change. So we're going to use the mode for nominal or discrete data. Because I get asked that a lot, like, what everybody uses the average, why all three? Well, they have different uses. That is all for today. We're going to do variance next time.